So here's what we're going to look at today. This is example 10. Example 10. And it's called an equation of a circle. Have you guys done circles in geometry?
Or not? I think a couple. Yeah, but I hated it. Oh, wait, a unit circle?
No, just equation of a circle. So x squared plus y squared equals r squared.
Like 9. We did that in 8th grade. Oh, yeah, we did that in 8th grade.
Okay. All right. So the question is, can the equation of a circle, which is x squared plus y squared equals, let's let it be 1. What that would do is that would graph a circle of radius 1. Okay, x squared plus y squared equals 1. Can it be expressed as a function? Can it be expressed as a function? Well, a function, f of x, is equal to y. F of x is equal to y. So the question is, can I rewrite this equation so that it's equal to y? Can we do that? Can we get y by itself? Yeah, sure, let's do it. Let's do it.
Alright.
What would you do?
Subtract the 1. Oh, wait, no. Subtract the x.
So subtract the x squared. I'm with you.
And then just square root it.
Okay, so y squared equals 1 minus x squared. I like it. And then he said square root it. So y is equal to the square root of 1 minus x squared. And that looks pretty dandy. Okay. When I square root, though, I have to consider what? The positive and the negative. I have to consider that there were positive options and negative options. Y equals plus or minus the square root. Okay. Well, by definition, a function has for every one input, there's only one output. But now if I put in any value for x, how many outputs am I going to get? 2. So can the equation of the circle be represented as a function? No, not unless I split it. If I split it and I say, okay, y is equal to the square root of 1 minus x squared, and also y is equal to negative square root 1 minus x squared. Each of these are functions. But this one altogether is not, because it's got 2 options for one input. Okay? If you were to graph this one, you would graph, if you graphed only the positive option, it would be the top half. If you graphed the negative option, it would be the bottom half. And each of those separately is a function, but together is not. Okay? So anytime you're having y is equal to plus or minus the square root of something, it's not a function. Okay? That's trying to help you with your homework. There's one where you have y squared equals, and you have to square root it to get y by itself, and that will not be a function. Okay? Okay. So let's go on here. This is going to be example 11. Example 11. Now, this is a really, really solid skill for you guys to have, so I want you to pay really close attention here. This is a function, and this function is called g of n. Okay? G of n. And it says evaluate g of 3. G of 3. So where is the 3 positioned? Is it the input or is it the output? G is the input. So our 3 is the input. So the in row right here, this is the input row. Okay? So if 3 is the input, then I go over to 3 and I say, what's the output when the input is 3? G of 3 is 7. Okay? It's very straightforward. But I'm telling you right now, my pre-cal kids struggle with this. G of 3 is 7. But now it says solve G of n equals 6. G of n equals 6. Is G of n the input or the output? Output. So the question is, what is n when the output is 6? 2. 2 or 4. Okay? So if G of n equals 6, n equals 2 or n equals 4. You just have to be able to read the table backwards. Do you see the difference? It matters where the number is. In part A, 3 is the input, so I read the top row. In the second one, 6 is the output, so I read the bottom row. Questions on that? I'm trying so hard to make this clear. I don't know why it's so hard for them, but it really is. So are y'all okay with this? Okay, good. Cheese? That's what she said? This is cheese? Okay. All right, well, let's try it on a graph. This is example 12. This is example 12. So can I do the same thing by looking at a graph? It says evaluate f of 2. That means what is y when x is 2? What is the output when x is 2? So I go over to x equals 2, and I slide up to the y value there. 1. So f of 2 is 1. Any questions on that? Okay. Then it says solve f of x equals 4. So that means y is 4. Y is 4. What are the x values where y is 4? 3 and negative 1. So f of x equals 4 when x equals 3 and when x equals negative 1. Everybody okay with that? Can we read it both ways? Yeah. Okay. Y'all are doing great today. Okay, here's the next piece of information. Oh, pause. Go over. This is something that we use really often. It's called the vertical line test, and you're going to want to write this down. I would draw this whole setup that you see on the board, and I'm going to pause it while you do that. And they came to me and they called it the pencil test, and then they did it wrong a lot because they didn't know that their pencil had to be vertical to run the pencil test. So I would make sure that you know that this is a vertical line test. If I try to draw any old line on this function, I'm not able to tell whether or not it's a function. The vertical line test is used because if you can draw any vertical line that intersects a graph more than once in any place, the graph is not a function. Okay? Anytime a vertical line would intersect more than once. So that takes us back to that circle that we graphed earlier. Remember, it was a circle of radius 1. If I were to run a vertical line test on this guy, I can see very clearly that it intersects twice, meaning it's not a function. But if I only run one piece at a time, now we're good, right? Each one of the top or the bottom pieces constitutes as a function because alone they pass the vertical line test. Together, the circle is not a function. Cool beans? Everybody understand vertical line test? No problems with that? Okay, thanks. You came back. This is good. Okay, the next piece of information, we're going to start looking at what they're calling toolkit functions in the textbook. So I'm going to pass out some papers to you, and then I'll be right back to finish this lesson. Change of plans. I'm going to do the toolkit part tomorrow. Today, we're going to finish homework in class. So that's all of the lesson to do the homework, and then we'll do the toolkit part tomorrow. Okay?